let's get started. I wanted to introduce myself. So I'm Bodo. I got funded by the Shuttleworth Foundation with a flash grant several years ago. Shuttleworth is a really interesting organization in that they encourage openness, they encourage open collaboration, they encourage sharing projects and open source, obviously, as well. And so within that spirit, I'd like to first spend like 10 minutes or so just giving a brief introduction to the work that I've been doing and some of the work that Shuttleworth has, the Shuttleworth Foundation has funded in part, and then also to reflect on what we can build on top of that. So the agenda is quite simple. Let me spend 10 minutes giving you a bit of an update or telling you a bit of a story. And then we open up to an open discussion and hopefully get everyone's input, and we can see if there's possible next steps as well. 10 years ago, I started working on a project to build a Google Maps for learning. It was designed, 10 years ago, my daughter was born, and I wanted to provide her a type of tool that could empower her to take her learning into her own hands. And so we started to build this Google Maps for learning. Now, at that time, my daughter was way too young. And so instead, I was helping other girls, mostly in East Africa, where I grew up, kids in refugee camps, conflict zones, places like that. And there were some really cool lessons learned that I wanted to quickly share with you because it influences where this project went further. So first of all, we're working with kids in refugee camps, conflict zones, disaster areas. These were kids that didn't go to school and they didn't have teachers. And so we struggled to encourage them or motivate them to learn things like 5th grade math or early literacy or early numeracy, things like that. They weren't really interested in those. They were interested in how to become a music producer. They wanted to build a bicycle mechanic shop. They wanted to open up a store on the side of the road. They wanted to do things that were real and that could impact them in their lives right at this moment. And so they weren't really interested in 5th grade math and early literacy and numeracy. And this was the stuff that we got funding for. And so there was a disconnect between what our funders wanted us to do and what the children actually wanted us to do. So that was a big lesson learned. 2, the big lesson was also about proof of learning. Proof of learning was really important to these kids because it allowed them to, for example, get a job, or allowed them to get to school, or allowed them to get a loan from a bank. So the proof of learning was something that's really tangible. And traditional assessments were really bad at providing this proof. And so we needed to pioneer different ways of proving learning, and also devise a way that we could propagate learning throughout the village if we ourselves and teachers and other educators weren't there to interact with the students. We were only working with students, and so or kids. The kids themselves needed to organize and teach each other. And so one of the key ways we solved both the proof of learning and the peer-to-peer teaching was to create a mechanism by which learners are teachers and teachers are learners. As soon as a learner learns a particular concept, in order for them to achieve mastery in that concept, they needed to teach 2 other kids in the community. These were the 3, we obviously learned a whole lot more, but these were the 3 key lessons. And so everything was going well until suddenly, and I just want to bring in a different story into the mix. My daughter suddenly became ill, and I was working on this project all for my daughter, and my daughter suddenly got ill. She became paralyzed over the course of several hours, and luckily her body regained most of her strength, but her left arm was completely paralyzed. So my daughter and I were stuck in hospital, and we're thinking, okay, well, her arm is paralyzed. It's not going to heal. So what are the solutions are there? And we thought, well, let's build a brain controlled exoskeleton. We know that her motor neurons are damaged, so maybe we can pick up a signal from her brain and we can overcome that challenge. And we didn't know where to go. There's no course that teaches you brain controlled exoskeleton. And much like the kids that didn't want to learn 5th grade math, we didn't want to learn all of medicine, or we didn't want to learn all of 3D printing. We didn't want to learn all of brain signal processing, for example. We just wanted to solve this one particular challenge and nothing more. And so we were thinking, well, maybe this Google Maps for Learning work that I was doing could help in this. And then we applied these lessons too. So we published our project openly. And what this allowed us to do was every time we published a particular problem we solved, experts from around the world came and helped us figure out better solutions to that particular problem. And then just very quickly, over the span of several months, close to a year, we ended up building this brain-controlled exoskeleton, which actually helped use a paralyzed arm again. And what was really awesome was that over the course of several months, it also allowed her to regain her motor neurons, which, first of all, the doctors said was impossible, and everyone said we could never hope for that. And now she goes around the world sharing her story. And so she's now also become a teacher. So she's actually teaching doctors about what she did, and she goes around the world. And we have a whole bunch of kids now building this project too. And so this is the backdrop of the lessons learned. And so what does this look like at a big grand level? If we look at proof of learning relies on middlemen at the moment. And the middlemen, these are the institutions, the colleges, they are skewing what learners and teachers want to learn and teach towards their own goals. And there's numerous examples we can share on that. Two is that the proof of learning mechanisms we use are really outdated. So this meme here is almost it's illustrative of the state of the art that we still use today. Is we use one size fits all standardized tests, and that's supposed to be a good assessment of someone's learning. And then thirdly, and this is confirmed by UNESCO, is that in the total budget being spent on education, 1.5 trillion is being spent on what could be regarded as bloat that is not helping either the learner or the teacher, but it's purely there to help the middleman. And so a potential opportunity would be, well, could we devise a win-win scenario, win-win economy where it's just the learner and the teacher interacting without the influence of a middleman? Could we optimize the proof of learning mechanism to include multiple different activities like the ones we tested out in East Africa? And then could we think of this 1.5 trillion bloat as being something that we could convert to $1.5 trillion of float, which is there as bounties to sponsor both learners to learn and teachers to teach. So instead of this 1.5 trillion going to middlemen, they get directed directly to learners who want to learn something and teachers who want to teach something. And I'll skip over this, but just very briefly, we have an opportunity to work to really focus on this particular solution for Web3 as an initial use case. The way that this works is, in order to create the underlying map on top of which this proof of learning mechanism works, we deconstruct learning. And this is the work that I've been doing for several years. And as a concept, it's pretty basic. You take educational content, you deconstruct it into these concepts that can be learned, and you map them out on this huge multi-dimensional latent space. You map the concepts to all the other concepts being taught, and then you load it up onto a device. Okay, let me skip forward. I know I'm spending a bit more time than I wanted to, but let me just skip forward. The whole engine of the proof of learning engine relies on the concept being taught. So to prove that you've learned the concept requires points. So let's say this concept being learned could be something like single digit addition or osmosis or maybe teamwork, any concept that can be learned. And to prove that you've learned this concept requires some points. And we've broken these points up into 3 levels: competent, proven, and mastery. Now, points decay over time, and this is important, right? If you learned something 10 years ago and you haven't practiced it since, you should no longer be a master in that, right? So point decay over time. And the decay function is different depending on what type of points you've earned. And then thirdly, how you earn points is done through multiple different activities. And here are some examples. So Really basic activities like viewing content and self-declaring allows you to earn up to 60 points within the competency level. In order to get proven points, you need to do things like traditional assessments, peer-to-peer reviews, QA interactions, things like that. But notice here that you aren't able to get to mastery just using these activities. To get to mastery, we employ the same mechanism we did in East Africa, where, well, you say you know what you're doing. Well, prove that you know what you're doing by teaching other people around you. And so you have to teach other people by generating content. You have to teach other people by producing projects that are related to that work. And it's through these mechanisms or these activities that you're able to get mastery points. And now the distinction we have, again, this is also something we did in East Africa, is that there's no distinction between a learner and a teacher. The only difference is related to the concept that's being taught or the concept that you're learning. If you have points between 0 and 200 in the concept that you're currently on, that means you're a learner. If, however, you've progressed to beyond 200 points, you're regarded as a teacher. So teachers are able to teach learners, and learners can increase their points by doing these types of activities. So what makes this really powerful, and I'll skip over this, but it's all based on the learning maps and the doing maps that I've been working on, and this consensus mechanism which we can use to optimize desired behavior. But given the time, I'll skip over that. And then very briefly, what I wanted to discuss or illustrate is that we can think of a new business model related to this. So core to the business model is the concept being the concept that should be learned. This could be anything from single digit addition, like early literacy numeracy points, but also things like Java programming or teamwork or whatever the case may be. There's three types of actors in this economy. There's investors. Now, investors are anyone who wants to learn or anyone who wants others to learn. So if you yourself want to learn, then the subscription fee you pay to the system goes into the treasury, which increases the value of the tokens that are earned when you earn proof of learning points. The second mechanism is by sponsoring others to learn. And so let's say you're a Google and you want your employees, let's say you're lacking Java programmers in your organization. Well, you can sponsor the concepts related to Java programming with additional with sponsorship, which increases the tokens that can be earned by learning this particular concept. Then we have learners. Learners can earn tokens by learning particular concepts. What I want you to notice here is that we're allowing a free market. We're allowing the market to determine which concepts are most valuable to learn. So, for example, the Gates Foundation, who thinks early literacy and numeracy is very, very important to learn, they could fund early literacy and numeracy concepts, whereas Google may fund Java programmers or Web3 content. Web3 folks can sponsor Solidity type concepts, things like that. So learners earn tokens by learning the concept. Learners graduate to become teachers. Teachers can then earn tokens by teaching other learners to become teachers. And it creates this positive sum feedback loop. And the last thing I wanted to share is that this feedback loop was really powerful in East Africa where we're working, because the teachers in this scenario, which were other learners, once they had taught all their other friends, they still wanted to achieve more mastery. And so they went out looking for other kids they could teach. And so there was this positive feedback loop where they themselves were going around into other communities, getting other teachers, other students to teach. I wanted to leave it there.
Just a question for me. Could you just unpack the middleman, right? How did that come to be? Because I mean, from my understanding, middleman in education is all around being a trusted broker between industry and the upcoming crop of learners, right? The industry needs someone to say, well, yes, this student is able to do this and meet these standards, and industry or whoever just trusts that, so that a student can progress within that system. Obviously, there are huge problems with that. But is that what you're talking about in this instance?
Yes. So the middleman is supposed to be that trusted broker. but do we? So the evidence shows that students aren't being prepared for the world that they're entering into. There's a disconnect, and this disconnect is often 10 years between what courses are being developed within schools and universities and what the market actually needs. There's often a up to 10, maybe 15 years gap between those courses and the need in the market. Yes, they are supposed to be the trusted brokers. However, they're not operating at the speed at which we need them to. And also, they're operating without us actually needing to have them anymore. If we think of anyone who wants others to learn, they are the ones that could and this is mainly the market, could determine, what skills do we need today. They fund the skills that are most relevant to them. And so here we have a free market mechanism by which whoever wants certain concepts to be learned has the ability to sponsor those concepts. So instead of waiting 10 years, there being a 10-year gap, we can have that in real time, that market dynamic.
Yeah, okay, no, thanks. I certainly agree. And in some instances, you have the tail wagging the dog, right? I mean, the choices of subject you teach are all, I mean, in the schools that my kids are in, it's all about the mathematics that they learn is all about how easy it is, or how, it's all about the teacher's ability to mark that and give a grade at the end of the day. And of course, the mathematics you learn in school is possibly the driest form of mathematics there is. And so you lose all sorts of inspiration for it. And, you go to first year university and your mind is blown by what mathematics actually is. And so there's a lot of those little, instances baked into that relationship.
One example here is, so we had quite a few kids who wanted to become bicycle mechanics. Now, in order to become a bicycle mechanic, sure, you need to learn some mathematical concepts. For example, you need to write an invoice. You need to know how to write an invoice. You need to know how to calculate the costs of certain items if you're writing a receipt. Or if you're applying for a loan, you need to build a very basic Excel spreadsheet for cash flow, for example. And so in order to do these things, you don't need to know all of fifth grade math. You need to know certain concepts. And these certain concepts are far easier to learn. You don't need to spend several months learning all of fifth grade math. You could learn these in a few afternoons and then immediately get positive feedback, positive input into what you're doing, because you're immediately creating this spreadsheet, which allows you to the bank or to a nonprofit and get some funding for the business you want to start. And these were kids between the ages of 7 or 8 to about 13, 14, right? They didn't need to wait until they had finished high school and before they started a business. They had a particular desire to do something in their communities, and they were empowered to do so from the moment they wanted to do that.
I have a quick question. Thank you so much. I'm a teacher and writer, and the idea of teaching early literacy and fifth grade math through the things that the students are interested in is such a profound concept that I wish more sort of standard educators and policymakers, at least here in the US, would understand. Because what I've seen all of this, not through data of what you've just described, but in the classroom, where like you teach them about, what music producers do, and then you see their literacy go up, you see their critical thinking skills go up. And I missed the beginning of your talk, apologies. So I'm kind of fascinated in this tool as a way of sort of closing the gap between learners and the disparity between minority students in the United States and say what white kids in the suburbs get. Yeah. So I just would love to hear you speak a little bit more on that. And if you've already covered that, apologies.
I think it's powerful if we're able to tap into the children's intrinsic motivation, then the world is open to. So coming to the story of my daughter, my daughter obviously was intrinsically motivated to build this thing, and the kids that we're working with were intrinsically motivated to become music producers or to become a bicycle mechanic or whatever. And the amazing thing is we tried everything to get them incentivized to do this. And usually there's teachers that use the carrot or the stick method, or maybe there's parents that use the carrot or the stick method to incentivize folks to do this. But once we were able to show kids, I'm messing things up here, but once we were able to show kids, well, here's the things that you need to learn in order to become a music producer. Suddenly we're tapping into their intrinsic motivation, and also it allowed them to see their progress towards that goal on a step-by-step basis. They didn't need to wait several years. And I think that's an important concept we can put at play, even in more traditional learning environments. Well, let's not get kids sitting in classrooms learning fifth grade math potentially. How about we get kids to work to solve real world problems? Maybe only for 20% of their time at school, or I'm envisioning a time where 100% of the time kids are spending at school, they're spending working on real world projects, solving real world problems.
I'm fighting for that future too. I hear you.
But perhaps we can take this one step at a time. Maybe we can aim for 20%. If we can get 20% of the time working on real world problems, I think that's going to be a really good step forward.
Thank you so much. I love this project.
Well, I think we come to the end of the talk, but if anyone's interested, here are my details. I appreciate your time and I appreciate you logging on, and I thank you for it.